In this video, we'll be recreating the Anemo Ring, Wind Current, and Fontaine's Hat Jellyfish mechanic in Mayasland Wonderland Beyond mode. We'll be focusing on using the Character Disruptor Device component to do so. To allow viewers to not have to wonder when they should pause when following along, if you see this kind of screen and hear this sound, pause and recreate on your own Mayasland Wonderland. There will be step-by-step instructions for what was covered. By following the steps on each of these pause screens, it will cover everything necessary. If you're just watching, just let it keep playing. Creating Anemo Ring. Let's hop into the Mayasland Wonderland editor and get started. We'll be making the Anemo Ring as a prefab. Making it as a prefab allows us to reuse and plop down as many copies as we want. And when we want to make any change to all of them, we can just change the prefab, and all the pre-existing entities on the stage will change. Let's switch to the prefab library for that. Because we'll be using just a VFX, we'll select the empty model. We won't need the native collision for this prefab, so go ahead and disable that. In the edit tools down below, we'll enable the Show Z-axis orientation. Type in Anemo Ring in the notes, and enable 3D notes. This allows us to identify the object in the editor, since we won't have an actual model and we'll be using a VFX for our Anemo Ring. We'll also change the prefab name up top to Anemo Ring. Now in the Components tab, select Advanced Editing under VFX Plane, add a VFX, and we'll change the VFX asset type to Looping Effect. Next, let's select the VFX Assets options and look up Horizontal Wind Current. You can click the Preview button to see what it looks like in action. Close out the VFX options. Down below, we'll press the Add Common Component button and select the Character Disruptor Device component. Click the Advanced Editing under the newly added Character Disruptor Device component. Located above, click Add. We'll be using an ejector type for this, so that doesn't need to change. We'll be keeping the default direction vector, but we'll change the motion velocity to 5, stable phase duration of 3, and decay phase duration of 1. You can adjust the velocity and duration to your own liking in the future, but the rest should be configured the same. Next, click the Trigger area. This is the area that will trigger the Ejectors effect on the character. We'll adjust the zoom multiplier to 3.5x and 3.5y. Close out the editing, and save the prefab at the bottom of your screen. Next, we'll be configuring the stage with prefabs and entities to play with. This is up to your own preference. From the static units and under the building structure selection, I'll drag out our slope structure. Next, to utilize the prefab we created, it'll be under the custom objects above. We didn't create a specific tab for it, so it'll be in the default and categorize tab. Drag it out to place it onto the stage. After configuring the stage with Anemo Rings and structures of your liking, you can select the top left grid-like button and select Test Play. Some noteworthy options here. The Cosmetic Display phase displays the following screen, and the Test Play segment displays this following screen when you quit or end the stage. You can choose your mannequin or mannequin to use in Test Play. In this case, I'll be using my mannequin. Now click Start Game. This recreation of the Anemo Ring isn't exactly like the one in Genshin, and I'll explain the details of how the ejector works in a later part of the video. Allow player to complete stage. For now, let's work on making the stage completable so we can see a stage complete screen at the end, instead of an incomplete screen. In the prefab library, select Dynamic Units. Under Gameplay Mechanisms, select Stone Elemental Platform. Open up the Model section and click Decoration Editor. Add decoration, expand the model selection, and add a model. We'll be looking for a wooden road sign. It'll be under Gameplay Mechanism. Disable the native collision and set the location to Y1.4. Close out the decoration editor and we'll name this prefab platform _ finish. Next, go to the Component tab, add Common Component and select the Tab component. Go to Advanced Editing. Under the Tab component you created, we'll change the prompt text to Finish Level. Switch to the Trigger option area and change the zoom multiplier values to X free, Y free, Z free. Then change the center Y to 2. Save the prefab at the bottom. Next, we need to add a node graph for it, which will be in the node graph section on the 4th tab. To have a node graph to add, we need to open up the Meliastra sandbox. On the top left corner of the screen, click the grid-like icon, and then go to the bottom left of the screen and click the Meliastra sandbox button. This should open up the sandbox window. It might be on another monitor or may take some time to load. Once you have the sandbox open, go to the server node graph, Entity node graph, the default tab, and right-click to create a new node graph. Right-click the newly created node graph to rename it. We'll rename it Finish Level on tab. Double-click to open it up. And we'll be adding some nodes. Right-click to bring up the node library and type in when tab is selected. This brings up the event node we need. Next, add in the node, get player entity to which the character belongs. Drag the selector entity output from the event node to the input character entity. Next, add in the execution node, set player settlement success status. Drag in the output pin of affiliated player entity into the input player entity. Change the settlement status to victory. We can then connect the events node execution path to the set player settlement success status node. Finally, add in the node settle state and connect in the execution path for that. Ctrl S to save the node graph, or you can click the save button below. Next, we can return back to Genshin. In our node graph tab for our Anemo ring prefab, click add node graph and select the node graph we created. Save the prefab. Now that we have that prefab created, we can place it onto our stage. And then we can test play. Make sure enable test play settlement is on. Let me explain how Ejector works. An ejector has these following settings. The stable phase is how long the ejector will influence the character at the specified motion velocity. The decay phase is how long afterwards that motion velocity gradually goes to 0. Some other interesting points to note about ejectors includes: ejectors can lift the player off the ground, ejectors can negate gravity, only one ejector's influence takes effect at a time, ejectors when influencing an upward or downward force turns off the character's glider. Ejector's influence to the character stays even if outside the trigger area. Creating wind current. In this next section, we'll be creating a wind current in Meliastra Land Wonderland Beyond mode. Let's head to the prefab library. This will be similar to how we made the Anemo ring. We'll start out with an empty model. I'll name the prefab wind current. Disable the native collision and add in the notes wind current to the edit tools. Make sure to tick on the show 3D tools if you want to see in the editor. We won't need to enable the show z-axis orientation for this, since the wind current will be pushing upwards. Next, go to the Components tab, click Advanced Editing under VFX Plane, add VFX. Change the asset type to Looping Effect. We're looking for wind current related performance. We can also add a second VFX, change it to Looping Effects 2, and look for Rising Wind Current. We can preview them both together by clicking the Preview Combination button, clicking the check mark for both of them, and click Preview Selected option. Let's exit the Advanced Editing of VFX. We're adding the common component, a Character Disruptor Device component. Unlike the Anemo ring, this time we'll change the device type to Force Field Device. We'll change the outer sphere radius to 10 and inner sphere radius to 8. These are two spheres that have their own dictated velocity. Under direction vector, we'll change it to y1 and change z to 0. This points the direction of the force field up, as you can see from the 3D arrow. Next, we'll change the inner diameter velocity to 8 and outer diameter velocity to 0. Switch to the trigger area section and change the center y to 5 and zoom multipliers to x4, y10, z4. It should look something like this. By setting the inner sphere to its velocity of 8 and outer sphere to a velocity of 0, we make it such that the area between the edge of the inner sphere and the edge of the outer sphere has a transitional speed from 8 to 0, such that as the character approaches the edge of the outer sphere, the velocity influence gradually goes to 0. Make sure to save the prefab. Hiding object model for editor usage. Now, before we actually put it onto the stage, it's hard to tell how far the influence is from the editor, unless we click on the entity and check the disruptor component. We can solve this by giving it a model, but make the model invisible when in game. In the prefab library, select our Wind Current prefab, and click Decoration Editor under the Model section. We'll add a decoration, and select the model asset under the other category, Wireframe Cuboid. Next, turn off the native collision for it, and set the location Y to 5, zoom to X4, Y10, Z4. These are the same values we set for our trigger area for our force field. We'll click on the three dots on the top right to rename it. I'll name it Outer, to signify where the outer sphere actually influences within the trigger area. We'll do the same thing and add another decoration with the same model asset. Disable the native collision, but this time we set the location Y to 4, zoom to X4, Y8, Z4, and rename it to Inner, signifying the area where there's 8 velocity applied to the character going upwards. Remember to save the prefab. Next, we need to go to the Combat Preset module. Click Unit Status on the left and select New Status. I'll name the status Hide Object Model. Set the infinite duration to on, switch over to Effect Details, click Add Effect below. We're looking for Object Invisible. This doesn't hide the VFX, so this will be handy for us. Save the unit status. Back to the prefab library, select our Wind Current, go to the Components tab, under Unit Status, click Advanced Editing. Click Add Status and select the unit status we just made. Since we're on this screen, let's also do the same thing for the Anemo ring. Click on the Anemo ring we previously created. Go to the Decoration Editor under the Model section. We'll do the same thing and use the same model asset. For this decoration, we'll rename it to Stable, signifying the range of the stable phase. This is how far we can expect the player to travel at stable velocity. We'll set the zoom to X3, Y3, and Z to 15. Since our stable phase is 3 seconds at 5 meters per second, 3 times 5 is 15, and that's the Z value. We'll set the location of Z to 7.5, that's half of 15. Make sure to change these Z values if you change the Anemo ring speed different than mine. Remember to disable the native collision. Next, we'll make another decoration. Same thing, but we'll name it Trigger. This signifies where the trigger area is for the ejector. Make sure to disable the native collision and set the zoom to X 3.5, Y 3.5. One final decoration with the same asset. We'll disable native collision, rename it a Decay. This signifies the area where we expect the player to be under the state of the decay phase duration of the ejector. I'll set the zoom to X 2.5, Y 2.5, and Z 5. The C value is from a duration of 1 second where it gradually goes from 5 meters per second to 0 from the ejector. And then I'll set the location Z value to 17.5, which is 15 plus 2.5, where 2.5 is half of 5. Remember to save the prefab. An important fact to note is that the character can move beyond these boundaries after touching the ejector. These would just serve as visual guidelines for if the player isn't moving. Next, go to the Components tab. Under Unit Status, click Advanced Editing. We need to make sure to add a unit status that hides the object. Now, if we go back to our stage, we can see the Anemo rings placed before has those wireframe models. I'm going to go ahead and rearrange my stage, and also to make use of the Wind Current prefab we made. Now, if I test play, the wireframe models are not visible to us. Now let me explain how force fields work. I previously already explained how the outer and inner sphere works, so let me note some other interesting traits of the force field. Multiple force fields can apply their influence to a character at the same time. Thus, they can negate each other's influence if they're in the opposing direction. Force fields' influence to the character only exists within the trigger area. This is different from the ejector. One ejector and multiple force fields can all apply influence to a character at the same time. Force fields only apply influence upward or downward if the character is flying or during the initial part of the jump animation. Creating Hat Jellyfish. In this last section, we'll be recreating the Hat Jellyfish from Fontaine. Let's start off in the prefab library and drag an empty model and name it Hat Jellyfish. Disable the native collision. We'll drag on an empty model, but this time we actually do need to use a model. So go ahead and click the model assets under the model section to add a model. We're looking for target balloon, specifically this chunky looking. It has a preset status that allows us to animate it. We'll get to that later. Let's first shrink it down a bit by adjusting the zoom to 0.5 on all three axes. Now let's hop to the Components tab and add a common component. Select the Character Disruptor Device and go to Advanced Editing for it. This time we'll be utilizing the Traction Device type, so change it to that. Next, we'll set the offset under Traction Destination to Y15. This puts the destination all the way up. We also set the radius to 2. This is the radius of the area that is considered destination. It might be hard to see. Let me just move the camera a bit so it's easier to see the blue sphere. Next, we'll set the motion velocity to 6, stable phase duration of 3, and decay phase duration of 1. We'll also enable stop when reaching the destination. Otherwise, if it somehow reaches the destination, it'll just go back and forth at the destination. Switch over to the trigger area, and we'll change the values zoom to 3 across all axes. Save the prefab. Now if we go back to our stage and place our Hat Jellyfish and test play, it works, but there's still quite some work for us to do, like animating it. Animating with preset status. Let's hop back to the prefab library. We'll need to configure some stuff. Select our Hat Jellyfish prefab and go to Advanced Editing under Character Disruptor Device and set the initially effective to No. This makes it so that our disruptor won't be effective until we toggle it otherwise from some means. Next, we also increase the trigger area's zoom multiplier to 5 across all axes. We'll need this to make sure the traction device is more reliable to launch the player under latency. Do a quick save. We'll then need to add a new common component for our Hat Jellyfish. This time we'll be utilizing the collision trigger component. Click Advanced Editing under Collision Trigger, add a new trigger, and change the effective target to only characters. We don't really need it to trigger when any other objects or creations such as monsters enter this trigger. Next, set the area's zoom multiplier to 5 across all axes. Save the prefab. Now let's open up the Meliastra sandbox. Under Server Node Graph, Editing Node Graph, we'll create a new node graph and name it Hat Jellyfish _ collision. Double click it to edit. And we'll be adding the event node when entering collision trigger. This event triggers whenever any effective target of the collision trigger enters it. Next, add in a start timer node. We'll set the target entity to self. The targeted entity is basically who is listening to this timer. In this case, our Hat Jellyfish will be the one listening. Next, set the timer name to delayed launch. This allows us to identify which timer is which when listening. We'll also be utilizing this timer to delay the activation of the traction device. Set the loop to no, since we don't want the timer to repeat. Drag out the timer sequence, and I'm looking for assembly list under general. This gives us a list of float values of when the timer will trigger. These are in seconds. So I just want the timer to trigger once, and that's in 0.5 seconds. So I'll put 0.5. Connect the execution path. Next, we want to add a node, set preset status. The target entity will be self. That is the Hat Jellyfish, the one with the model. We'll set the preset status to 1. As for the preset status index, we need to go back to Genshin. Select our Hat Jellyfish and under Model's Preset Status, click the copy icon next to the preset status index. We'll paste that value into the node. Next, we need to actually respond to the timer firing. Let's add in the node when timer is triggered. Drag out the timer name output and search for the equal operation node. We want to check if this timer triggered is for delayed launch, so that'll be the second input for it. This returns true or false, so we can drag the result output and search for the flow control node branch. We can then drag the execution path from the event node to the flow control node. Next, add in the node set character disruptor device. and drag the execution path for yes from the branch to it. We'll put self-entity to the target entity input because the Hat Jellyfish has the traction device, and that traction device is device ID 1. Next, add another start timer node. The target entity will be self-entity. Timer name will be reset launch. We'll be utilizing this to reset the preset status back to 0 so it can be toggled back to 1. Loop set to no, we don't want it to repeat. For the assembly list, we want it to trigger 1 second later, so put in 1. Next, go back to the when timer is triggered node and drag out the timer name again. Search for the equal node, and we want it to be checking if it is named reset launch. I'm just going to click on the double branch and Ctrl-C, Ctrl-V to copy and paste it. Plug in the result to the condition and attach the no from the first branch to the second branch. Now if this second branch's condition is yes, meaning is the timer for reset launch, we want to turn off the disruptor device. So let me just copy those nodes, connect it, and change the device ID value to 0. 0 means there's no device. Next, I'm going to copy the preset status nodes, connect the execution path, and change the preset status value to 0. Remember to save the node graph. Now let's go back to Genshin, select our Hat Jellyfish prefab, and under node graphs, add the Hat Jellyfish _ collision node graph we created. Save the prefab. If we go and test play, we can now see the model animating as the preset status changes. The traction device is also activated 0.5 seconds later, which matches the animation. Everything is then reset, so it can do it again when the character enters the Hat Jellyfish. Creating suction effect. Now that's all good and well, but we can do better. In the original Fontaine's Hat Jellyfish, the player gets sucked in. We can add that effect in. Because we can't have two active Character Disruptor Device on an entity, we'll need to make a new prefab. Let's head over to the prefab library. And yet again, we drag an empty model. Name it Force Field Trap. Disables native collision. Go to the Components tab, add a Character Disruptor Device component, and click Advanced Editing under it. Change device type to Force Field, Inner Sphere Radius to 2, and this time we're changing the disturbance direction from a specified direction to line connecting sphere center and the trigger area. This basically makes the disturbance direction a constantly changing line, which depends on where the character is in relation to the sphere's center. We want that line orientation for both inner and outer sphere to be towards the sphere center, so that it pushes the player in. Set the velocity for both to be 8 meters per second. Next, switch to the trigger area section and change the trigger area shape to sphere, and set the radius to 2. Save this prefab. Now let's hop back into the Miliastra sandbox, and under Server Node Graph, Entity Node Graph, we'll be creating a new node graph. Name it Hat Jellyfish _ created. We technically can use the Hat Jellyfish _ collision node graph for this, but we'll just use a separate node graph so it's easier to see. Open the Hat Jellyfish _ created node graph and add in the event node when entity is created. This event is called whenever the entity that this node graph is attached to is created. Add in a create prefab node, plug in the execution path, and we're going to need to go back to Genshin. Click the Force Field Trap prefab we made, and click the copy icon on the top right below the prefab name. Then we can paste it into the prefab ID input for the create prefab node. Next, add in a get self entity node. Drag its output out and search for get entity location and rotation. Plug the location and rotation to the corresponding inputs to the create prefab node. Self entity to the owner entity, overwrite level to no, and the rest we can leave as is. Next, add in the node set custom variable. This will let us store the force field entity as a variable for later use. Plug in a self entity node to the target entity because we want to save this variable onto the Hat Jellyfish. Variable name will name it force field entity. Plug in the created entity from the create prefab node into the variable value and set the trigger event to no. Now we can go back to the Hat Jellyfish collision node graph. We're going to move these nodes farther back, disconnect the link here by right-clicking it, and I'm going to have another set Character Disruptor Device node. Change the device ID to 0, plug those execution paths back up, And what this node is going to do is turn the force field off. So let's add in a get custom variable node, and it's going to be from get self entity node like this. Plug that value in and set the variable name to force field entity, because that's the name of the custom variable we put in earlier. I'm going to do the same thing down here, except we'll be turning the force field back on. So let me copy these, reconnect the execution paths, and change the device ID to 1. Alright, make sure to save. Now, head back to Genshin and make sure you have the Hat Jellyfish selected. Go to the Node Graph tab, it should have the collision node graph already. We just need to add in the Hat Jellyfish _ created node graph. Save the prefab. Now, if we test play, you can see the character getting that sucked in effect. Sweet, is it time for us to actually use this Hat Jellyfish prefab? Nope, sorry, not yet. There's one more issue with this Hat Jellyfish. If you place this in the air and a player falls onto it, it falls straight through, like so. The reason is that our traction device only turns on 0.5 seconds later, and even though we have a force fields don't apply vertical influence unless you're gliding or the initial part of a jump animation. Which is why we need one more section before we can actually utilize this Hat Jellyfish. Negate gravity and hover. To fix this problem, we must first eliminate gravity. Let's head over to the combat preset module and select unit status on the left. Add a new status and name it High Player No Gravity, and set the initial runtime to 2. Over at Effect Details, we'll add an effect. Search for Fall Efficiency Change Value. And set the change value to -200%. This is the lowest it can go. At -200%, gravity is not applied. Next, add in another effect. Search for Character Hidden. We want this one too, so that we don't see the character awkwardly floating in mid-air when they're trapped in the Hat Jellyfish. You can't see the character in the original Fontaine version either. Lastly, add in another effect. Search for Disable Gliding. This one isn't mandatory, but just makes it so that they can't glide. And you can't hear the sound of the gliders being activated if they are in the Hat Jellyfish. One important thing to note here is that the character hidden effect takes in a Boolean local filter. By default, without a Boolean local filter, it treats it as returning yes. But you might think that's what we want, but when it returns yes, the character is actually partially hidden. What we want for it is to return no, which actually makes it fully hidden. So let's jump into Meliastra's sandbox and make a Boolean node graph. A Boolean node graph is client-side, meaning it runs on the player's machine instead of the server. We can find client-side node graphs by clicking the window button up top and selecting Client Node Graph Resource Explorer. Under Boolean node graph, the default tab, create a node graph. We'll rename it to Always No. Open it up. Because we can't just plug in a direct yes or no value, at least as of me recording this video, we will add in a logical not operation and set the condition to yes. Not yes is no, so this will always have an output result of no, serving the purpose of this Boolean node graph. Save this node graph. Return to Genshin. We can now select the Boolean node graph we created under the character hidden effect. Save the unit status. If we proceed to do the necessary steps to apply the unit status when the player enters the Hat Jellyfish, the player would still fall through. Why, you ask? It's because, yes, the gravity is no longer there, but gravity is an acceleration, and the velocity of the character accumulated from gravity is still there. That's why we need to do one more thing before we start applying that unit status that negates gravity. We need something to remove the velocity. There is one thing in Meliastra that can negate a character's gravity, and that is ejectors. By having the character be influenced by ejector when they touch the Hat Jellyfish, we can negate the character's gravity. So let's go to the prefab library, and for the last time in this tutorial, use an empty model as a prefab. Name it Ejector_negate. Disable its native collision. Go to the Components tab, add in a Character Disruptor Device component, keep it as an ejector, Set the direction vector of x0, y1, z0, so it points upwards. Now we just want a tiny influence, but it also needs to last not too short, otherwise things can bug out with latency, so set the motion velocity to 0.1 and stable phase duration to 0.5. Now switch to the trigger area, and change the zoom multiplier to 2 across all axes. Save the prefab. Similar to how we set up the force field prefab, let's head back to the Melastra sandbox, opening up the Hat Jellyfish _ created node graph, copy the create prefab and related nodes, connect the execution path, head back to Genshin and copy the Ejector _ Negate's prefab ID, paste that into the prefab ID of the second create prefab node. Next, let's open up the Hat Jellyfish _ collision node graph, and we're adding the node add unit status. Connect the execution path, drag out the entering entity from the when entering collision trigger node, and plug that into the application target entity. Head back to Genshin and copy the unit status config ID for the hide player node gravity status. The copy button is right under its name on the top right. Paste that into the node. Set the applied stacks to 1, and the rest we can leave as is. Save the node graph. Now, if you were to fall directly into a Hat Jellyfish, you won't fall through. Finally, we can now configure our stage to our own preference, move things around, and utilize the Hat Jellyfish we made.